All right. Solana mobile phone, aptitude test project. Few more questions. All right. Let's experiment with a new learning format today, guys. I have written some normal, easily actionable picture wali slides. At the end of the class, let's do a poll and understand, which format is better. Even though we'll go through the slides as well, at least towards the initial bits of understanding about program derived addresses in Solana, we're going to stick to the slides. Let me do a quick poll to understand how many of you already know this. Do you already know what a PDA is? Have you worked with PDAs in the past? Give me a yes or a no. So it's 85% no, 15% yes. Great. So in that case, we'll take it slow. Slowly, we will try to understand what are program derived addresses. These are specific to Solana. Why were they introduced? Or well, they weren't introduced. They've been here for the longest time. What exactly do they solve? What is the problem in the Solana blockchain for which you actually need these PDAs to sort of, create any decentralized application? If you want to create a decentralized Uber, if you want to create a decentralized lending platform, if you want to create something like a NFT marketplace, in all of these, you will be storing data in something called program derived addresses. We'll understand what those are. Before we start, there were 2 offline videos from last week. You should have gone through them. Even though this video doesn't necessarily is dependent on them, it's a good idea for you to keep wrapping up offline videos if you're coming to live videos. Both of them were posted on harkira.classics.co.in. They are yet to be posted on app.headexdevs.com. Whenever there is a video posted, it will first go to harkira.classics.co.in. So, if you want to find them earlier, just go over there. With that, let's start with what are program derived addresses. Wow, there are animations and everything. All right. What is the Solana blockchain? Firstly, the Solana blockchain is millions and billions of records or accounts with various owners. This we discussed last week. Last week we discussed what is an owner, how is it different from an authority. This is what the Solana blockchain looks like. It is a bunch of accounts. For example, your normal Solana wallet account. This is my wallet account that let's say has 20 Solana in it. This might be my friend's Solana account. Let's say this has 5 Sol, 10 USDC, something like that in it. These are the native accounts where we store our balances. This is the account that you create whenever you generate a public or a private key. We also saw the concept of owners last week. We said that these accounts are owned by something called the system program. The system program is a native program. It is a program that comes bundled with the Solana blockchain. And this system program is the owner of most accounts that you see on the Solana blockchain. Harkirat, what is an owner? An owner is a program that can change the data inside an account. A program that can decrease the lampposts inside an account. Any program, the owner of an account is a program that can, do these 2 things: decrease the amount of lampposts you have or change the data inside an account. If you are ever sending someone Solana, if Harkirat's wallet is sending Solana to Raman's wallet, you call a function on this system program. That is also something we saw last week. Okay, whenever Harkirat is sending money to Raman, he's actually calling a function over here. That function is debiting, let's say, 1 Solana from here, crediting 1 Sol into Raman's account. So this is what the Solana blockchain looks like. We are most of the times working with accounts like this. Let me quickly take an example over here. If I open my Phantom wallet over here, and this wallet, let's say, has 0.04 Solana. This is Harkirat's wallet, this wallet right here. If I now send some money to, let's say, an account over here, let's say a random account 14 over here. Let's say the amount is really small. I'm sending 0.004 Sol. When I click on send, what is happening? I am calling a function on the system program. How can I confirm that? If I look at this transaction, if I open this transaction, let's say in explorer.solana.com, in this transaction, I can see the third instruction over here. Ignore the first instruction, ignore the second instruction. It is something that Phantom adds. The third instruction here says what? System program : transfer. We are calling a transfer function on this program. This is similar to you calling a function on a smart contract in Ethereum. In case of Solana, when you are transferring SOL from one account to another, you are calling a function on the system program. The system program owns this account. The system program owns this account. It can transfer money from here to here. But there are other programs as well. Programs that you write. Programs that provide real use cases on Solana. This is the biggest difference between Bitcoin and Solana and Ethereum. Bitcoin doesn't let you create your own smart contracts. Ethereum and Solana let you do that. So the Solana blockchain has a bunch of programs like this. It also has a bunch of user created programs. For example, you might create your own Uber smart contract or Uber program tomorrow where you register users sign up. Whenever a user signs up, they store their first name, last name, address. You store that in a user one account for the first user. You store that if there was a user two account here for the second user. If there is a ride from point A to point B, you store it in a ride account. You create a fresh account for everything, and this account is owned by the Uber program. The Uber program can make changes in this account. It can change the data inside. If a user comes to your website and changes their first name, you send a request to the Uber program, or you call a function on the Uber program, it changes the data in here. And similarly, the very common token program we've seen many times until now. The token program, whenever you interact with it, you can create your own mint, you can create your own token. And whenever a user wants to buy your token, they will create an associated token account. And these associated token accounts are what store how much USDC I have or how much, bonk coin I have. So this is a high level of the Solana blockchain and how it looks like. Thousands of addresses, one address owned by another address owned by another address. If you remember from last week, this Uber program is also owned by something called the BPF loader. The BPF loader is the program that is responsible for pushing new programs on the Solana blockchain. So it's a very big web of accounts is what the Solana blockchain is. The token program, this one right here, what do you think is stored in this account? What do you think this account looks like? We have explored this many times until now. The token program is a smart contract that Solana engineers wrote and deployed on the Solana blockchain. So what does this token program account hold? It holds a lot of Rust code. It holds a lot of Rust code converted in a certain format. That is what is stored over here. This is the on-chain address of the token program. There are many token programs on Solana, but the oldest one, the one that you use most of the times right now, this is the on-chain address of it. You can actually go to this address and see that this token program has a bunch of data. This token program has executable set to true. If you remember last week we discussed what all things are stored in an account. Executable is one of those fields. Since this is a program, it has executable set to true. So will this, so will this. How many lampposts it has? It has a lot of Solana in it. Why? Because it will require a lot of space on the blockchain. It requires almost 134,080 bytes of space, 134 kilobytes of space, which is, a lot of space compared to these mini accounts that we have. These only store like bytes of data. But of course, the program, which has your complete Rust code, will need a lot of space. And hence, the corresponding amount of Solana that we have to store here is also a lot. Who is the owner of this? I told a while back, all of these are owned by the BPF loader. What is the BPF loader program? This program right here. This is the program that lets you send new programs on the Solana blockchain. It is a program, a native program similar to the system program. BPF loader is a native program. All of these are owned by the BPF loader. You interact with this program anytime you want to create a fresh smart contract, anytime you want to update an existing smart contract. So this is what the fields look like. If you would have looked at the data field over here, it would have been a very big blob of data or, very big Rust code converted into certain format. That is what this token program account is. You can also explore it on chain. This is the original Rust code for it. If you want to look at the Rust code of this token program, you can look at it over here. That is one kind of account that we store. This is not a PDA. This is not what we're learning today. This is a program. What are we learning today? We are learning program derived addresses. We are learning something new called program derived address. How can we have an address that is derived from a program? This mint account is the second type of program we want to learn about, which is account which is created whenever a user wants to create a new mint or a new token. If today you want to create a Kiyat coin, you create a fresh mint account first. That is the first thing you do. Hopefully we remember this until now, and How can you create this? We have created it many times by running spl dash token create dash token. If you have the Solana CLI, it is as simple as running this command. It creates a fresh mint account on chain. So it is this easy to create a fresh mint account on chain. Now this mint account also needs to store some space. This mint account also needs to have some data in it. More specifically, as you can see, 82 bytes of data. So you have to store some lamp ports in there. But this isn't a program. This isn't a program. It just stores things like who is the freeze authority of this token, who is the mint authority of this token, how many decimals does this specific token have. That is what is stored in this space field over here. And if you look at the data, isn't a lot of data that is stored over here compared to what is stored in the token program. Is this a PDA? The answer is no. Even this is not a program derived address. In case of Solana, when you are creating these mint accounts, if you remember from last week we inspected the create mint function. We saw that we were creating a fresh key pair whenever we were creating this mint account. If you don't remember this part, it's fine. You can go back to the video from last week, but this is not a program derived address. This is a normal address. You create this account address, you assign its owner to be the token program whenever you create it. Whenever you create a mint account, you put some data in it. Specifically, if I again open the terminal, the data that you store in this account is who is going to be the mint authority, who can mint tokens on it. By default, it is going to be my address. This is the address whose private key I have currently on my machine. If I open this on chain, on DevNet, you will clearly see what data is stored inside it. This has 9 decimals. This is the mint authority of this token. So this is the data that is stored in 82 bytes of code over here. This is the data that is stored over here. This is the base 64 representation of this data. That is the second kind of an account. The third account in case of token program is the associated token account. This is a PDA. This is a program derived address. We will understand very soon what are program derived addresses. But what does this look like? This is again an on-chain ATA of mine. This ATA is my USDC associated token account. If you open this, you will see this is an associated token account for USDC on Harkirat's wallet. If you look at it, this also takes 165 bytes of data. This is the data that is stored over here. Its owner is also the token program. So ATAs are also owned by the token program. Mint accounts are also owned by the token program. There is perfectly audited code written over here. Whenever a mint account is created, the token program won't change anything randomly in there. The token program won't increase someone's balance to $1 million USDC. This code is very well audited. Only if either the mint authority mints new token, yahan pe the balance goes up, or if I send this token to a friend, the balance gets deducted from here, it gets added over here. So the token program is very well audited. Everyone trusts the token program. It is available on GitHub, you can see. And hence all of these accounts, even though they are owned by the token program, even though ideally the token program can, do shady things in here, because an owner can always change the data inside. Ideally, this can change all the data inside. Does it happen though? No, because this program is well audited. इसमें clearly लिखा है कि the only way this guy's balance can be decreased is if this guy signs a transaction to transfer it to a different person. Similarly, the program clearly says कि only way the account balance here can be increased is if either new tokens are minted by the mint authority, or if new tokens are transferred over here. So these are the 3 kinds of accounts that exist in case of Solana, or more specifically in case of the token program. But the question is, I kept on saying this is a program derived address. What does that mean? Does this program derive this address? Does a different program derive this address? What does it even mean for this to be a program derived address? That is what we're going to learn today. Difference between an ATA, this associated token account, and this mint account. I hate these animations. This is a program derived address. This is a normal account, an account which has a public and a private key. This user account does not have a public or a private key. It has a public key, it does not have a private key. You can create accounts that don't have a private key on the Solana blockchain. That is one of the properties of a program derived address. ये जो user1 ATA है, this user1 associated token account, it is owned by the token program. It is derived from some different program. But this account does not have a private key. It only has a public key. It is not like I have forgotten its private key. It's like it doesn't have a private key only. Mint account does have a private key and a public key. You can't do much with its private key because this is owned by the token program. तो इसकी private key के साथ आप कुछ कर भी नहीं सकते. You can't do anything with its private key anyways. But the user one associated token account is a program derived address, is something you don't have the private key for. No one has the private key for it. This account doesn't even have a private key. Correspondingly, if you create an Uber program in the future, right? If you create an Uber program, you will also have these as program derived addresses. What is a program derived address? We'll come to very soon. But if you create a Uber program in the future, the place where you are storing the user's data, the write one data, the write two data, these will be program derived addresses. But the question is, what is a program derived address? Before that, this is a chart of what is the difference between this guy and this guy. There are not a lot of differences. Both of them have executable set to false, both this and this. Both of them, this guy has 82 bytes of data, the other guy has 165 bytes of data. Both of them are owned by the token program. But is the first one a PDA? No, this is not a program derived address. Is the second one a PDA? Yes, this is a program derived address. Question is, what is a program derived address, Sarkirat? Let's look at the official definition. A program derived address provides developers on Solana with two main use cases. Number one, deterministic account addresses. Deterministic account addresses. What does that mean? If I have this associated token account for user 1, I should be able to reach that deterministically. If today I only know that this is the token program ID and this is the mint account and this is the user one public key. I repeat, अगर आज मुझे पता है कि यार ये मेरा friend है, this is my friend, let me open it. This is my friend's public key, let's say. Let's say today I come to know that this is my friend's public key. I should be able to do some paper math. I should be able to take their public key. I will take their public key. I will take the token program ID address. I will take whatever is the address of the token program. Let's say it is this. And I will take here what token do I want the balance of Harkirat? Let's say USDC. Whatever the USDC token mint address is. Let's say that is, some random address like this. Given these three things, I should be able to deterministically derive कि इसका associated token account ये होगा. I should be able to derive somehow this plus this plus this. Now how is that addition happening is a different question. How can you take these three and deterministically push out a new program derived address is a different question. But that is what a property of a PDA is. What is the property of a PDA? Deterministic account addresses. If I want to see how much USDC my friend has, they can either give me their associated token account. कि यार ये रहा मेरा associated token account, जाके देख ले इसके अंदर कितना balance है. For example, currently if I open my wallet, you will see it has 13.94 USDC in it. But let's say my friend doesn't give me this. My friend simply gives me their public key. Here is my public key. Figure out how much USDC do I have. So what can I do? I can be like, I know your USDC is stored in this associated token account. Where is this USDC of mine eventually stored? This number 13.94914. This is stored in an associated token account. This is stored over here in my associated token account. If you remember from a while back, I showed you, this is my associated token account for USDC. Let me open it on chain. For this wallet of mine, the associated token account for this 13.9 USDC is this right here, 2AQ, whatever this is. If I open this, it tells me this is an associated token account जिसका mint है USDC and balance is 13.94. So my friend can either send me this, this is my associated token account, or my friend can send me, they can either send me this, this is my associated token account. यहाँ पे जाके देख ले how much USDC I have. Go over here and see how much USDC I have. Or they can simply tell me कि this is my public key, this is my public key. Figure out how much USDC I have, and I will be able to, given their public key and their token account, and the token program ka ID जहाँ the token program is present, and the USDC mint account. What is USDC mint account? This account right here. So this third mint over here. If I take these three, this plus this plus this, I should be able to derive this program derived address. So what is a PDA? It is a deterministic address. Deterministic का मतलब है कि it is made from some what are called seeds. I repeat, introducing a new term over here called seeds. कि यार given this seed plus this seed plus this seed, इनको तीनों को add कर दो, तो this PDA pops out, and then you can go on chain and see how much USDC does Harkirat have. Do we understand this high level little bit? कि a PDA can be derived from some seeds, and for the token program, the seeds look something like this. I'm sure some of you or most of you don't understand it, but let's do a quick poll to see where we are at currently. How are we doing, guys? Do we understand this little bit? We do not understand this at all. कोई issue नहीं है. Let's try to look at some code maybe. Before I do anything at all, let's try to create a token. Let's pause the slides for a moment. If you remember, how did I create a token until now? I ran spl-token create-token locally. This created a fresh token on DevNet for me. This is a new token mint. What is this address that I have just created? This address is the mint account that has been created for a new token. If I look at this on explorer.solana.com, what do I see? If I change this to DevNet, I see that an unknown token has been created. Iski current supply 0 hai. That is the first thing I did. Now I will create my associated token account. I will create this account right here. How can I create this account? To create this account, what was the command if you remember? SPL token create-account and then the token address. क्या एक associated token address बना दो for my public key and for this token. Hopefully we understand / remember this. कि this specific command SPL token create account token. यार इस token का for this token on my address create an associated token account. यहाँ पे मैं अपना token balance रखूँगा. My token balance will be kept over here in my user's associated token account. This is how I created this associated token account. SPL token create token. इस token का associated token account बना दो मेरे लिए, for me. And then the third thing was actually minting some token. So SPL token mint, and then what was my associated token address? मेरा associated token address क्या है? What is my associated token address? It was this. And how much tokens do I want to mint? Let's say I want to mint 100 of these tokens. So if I run this, it says cannot find mint account this thing. The third argument here is the mint address and not my associated token account. So the third argument here is this token address. कि यार इस token के 100 tokens मुझे mint कर दो. मेरे associated token account यहाँ पे mint कर दो. If I press enter over here, it says minting 100 tokens. 100 tokens will reach where? It will reach here. Here the balance will become 100 because I just minted 100 tokens over here. They don't reach if this is my public key, this data isn't stored over here. Ki Harkirat has 100 of these tokens. This data is stored in my associated token account. Token program say I created a mint account. Token program say I created an associated token account. Notice the 3 public keys that have been created. The first public key is this public key right here. When I ran, not this one. This public key right here. When I ran create token, that created what? That created this mint account. The second was this public key. which created this guy. And the third command that I ran actually put plus 100 over here. Do we understand this much? The three commands that I ran on the left: create token to create this, create account to create this, and mint to actually put 100 tokens in here. Do we understand these three commands and the set of accounts that have been created until now? We understand this. 86%. Good, not great. Given we understand this, what I'm saying is कि ये जो account बना ना, this account that has been made, I can derive this account's public key. What was this account's public key? This one. This can be derived from जो token है, the token program का public key, mint account का public key, and the user का public key. 3 seeds. This account's address, इस account की public key, this user one ATA's public key can be derived, can be somehow calculated given this token program का address, mint account का address, and this user का public address. Let's see this in action. Let's look at that code. You will not understand the code that I'm going to show you right now. This is the code that will come at the end of the class. But if you open the slides for today, if you go to projects.100xdevs.com, if you scroll down to ownership, authorities and PDAs, this is the slides from last week. And इसकी जो last slide है, program derived addresses, the last slide here has some code written. You don't have to worry about the code that is written. Don't worry about the individual function calls, a lot of complicated code. But let me show you how can you derive this account address given these inputs. जो मैं यहाँ कह रहा था, the thing that I was saying here, कि given some seeds, seed 1, seed 2, seed 3, you can derive a program derived address. Let's look at the code and see if that actually happens. You don't have to run it locally. Let me just run it on my side and little bit take you through the code. Eventually we will go through this code properly. But if you look at this code over here, I have only described 2 variables. कि यार ये रहा user का address, this is my friend's address, and this is the mint. This is which token this is. Is this USDC? Is this Harkirat's token? These are the 2 inputs. That is the only thing I've explicitly defined. And then take this as a black box. Don't worry about what this function does. But notice this function takes 2 inputs. The mint address, which is this thing, and the owner address, which is this thing. It takes 2 inputs and it spits out the associated token address for this user. ये जो address था, let's keep this address over here. Let me open the code on the right again. I am going to take 2 inputs. Input number 1, my public key. What is my public key? When I ran Solana address, this is my public key. And what is my token mint address? What did I just print right now? Or what token did I create? I created this token right here. Given these 2 inputs, what can I log? What gets logged over here when I call a function? What is the code doing? Given these 2 inputs, I call a function which returns something. But when I log what that function returns, if I run this, what gets printed? 4KSGR. Is this the same as this? It is. So, was I able to derive this specific public key from जो मेरा friend है या फिर my own public key and the token mint address? Given these 2 inputs, I was able to derive कि यार ये है इस बंदे का account address. That is what a program derived addresses. What was the property of PDAs that we were looking at? Where were we in the slides? In the slides, we were here. What did we say? We said a program derived address provides developers on Solana with 2 main use cases. The first one being deterministic account addresses. PDAs provide a mechanism to deterministically derive an address using a combination of optional seeds and a specific program ID. Ignore the second part for now, specific program ID. But given a bunch of seeds, what do I mean when I say seeds? I mean, ये 2 inputs. Given these 2 inputs, this is my user's, my friend's address. This is the USDC token mint. Give me the corresponding associated token address. It isn't a random public key. my associated token address for a given token is not something random. It is deterministic. It can be determined given a user address and a token mint address. Do we understand the first statement here now? I'm going to now explain it very pictorially as well, using a Web2 example. But before that, are we a little more comfortable with PDAs? The first property of PDAs provide a mechanism to deterministically derive an address using a combination of optional seeds. Do we understand this little bit? We're going to go through it again. Sort of we understand. Great. 88% is not bad at all. Cool. Sort of we understand. Why do you have to do this though? Why can't every address be something random? What benefit does a deterministic account address give us? Let's understand that next. There are 3 jargons you need to know when you're learning PDAs. Seeds, understood a little bit. Bump, we are going to learn about the bump. And the fact that these public keys are off the curve. These are 3 jargons you need to know of. Even if you don't, that is fine. But let me give you a brief of what this is. Seeds, a bunch of inputs, a bunch of words used to derive an address. In our case, those words were, this public key and this public key. So a bunch of words that are used to derive an address are what are called seeds. Bump, we'll come to bump when we reach the code finally. As you can see, this function returned me 2 things: associated token account and a bump. We will learn what this bump is very soon. And it's a very interesting concept. The third thing is PDAs that we are generating don't have a private key. If you remember, we said that the Solana blockchain generates public private 5519 curve. Do you remember this? Okay. On the Solana blockchain, the public private keys are generated on a curve. What does off the curve mean? That ये जो public key है, that doesn't lie on that curve, which basically means it doesn't have a corresponding private key. It is still a public key. ED25519 curve, which is why it doesn't have a corresponding private key. It is a random string that doesn't lie on the ED25519 curve. If this is the ED25519 curve, there are some points on this curve. Those points have a public and a private key. What does off the curve mean? That the program derived address that we are generating, this, as I said, I'm saying this again and again, this is a program derived address. This doesn't have a corresponding private key. It only has a public key. Let me do one thing. Can I somehow disable animations when I present? I cannot. Never mind. All right. These are the 3 jargons. If you don't understand them, we will come to them slowly as well. Let's take a simpler example. How do you store data in the Web2 world? Have you ever put data in a database in the Web2 world? Some of you might have last week in our web dev class. Some of you might not have. But this is this concept of databases in Web2 where you store your data. For example, let's say you are generating a similar use case in the Web2 world. In a Node.js, you have a Node.js server where people can create tokens and give each other balances, whatever. How will you store that data in an SQL table? Now, if you don't know SQL, this will be a little overwhelming. If you know MongoDB a little bit, you probably won't be able to follow along this example. But the people who do know SQL databases, can you see that this looks like the right schema for our table? In the Web2 world, if I'm creating a simple token-like application, I would have a table called user balances, where I would have 3 columns: token mint, address, and token amount. These are the 3 columns that I would have. What is the token mint? This is कौन से token की बात हो रही है? USDC, USDT, Doggy, Bonk. For people who really know SQL well, you would know that this would be a foreign key to some other table. If you don't understand that, that is fine. But this is how the table would look like in the Web2 world. Okay, Harkirat has $100 of USDC. Raman has 140 tokens of Doggy. Jyoti has 200 tokens of USDT. Poonam has 400 tokens of Bonk, so on and so forth. You would have a very big table which has millions of records, which stores everyone's balances. What does every row over here represent? For example, a single row like this represents Poonam's Bonk balance is 400. Poonam's Bonk address is 400. Poonam's public key and the Bonk address ka public key can derive how much token do they have. So these two are the sort of inputs that derive this. These two would be the primary key of this table for the people who understand primary keys in SQL. Okay, this will always be unique. Okay, given a person's address, Harkirat's address, and given a token mint USDC, there will be a single row. इसमें दो rows थोड़ी होंगी जहाँ लिखा होगा कि USDC Harkirat has 100 and USDC Harkirat has 500, let's say. No, there will be a unique row कि USDC Harkirat has 100 and USDC, let's say Raman has 200, so on and so forth. Token mint plus address will always lead to a single row. You will not have two separate rows कि USDC Harkirat 100, USDC Harkirat 200. Of course, you will not have that. These two are the primary key of this table. The pair of the token mint and the address are the primary key. So Poonam's bonk balance is 400. That is what this row means. What does the row right above it mean? Okay, Jyoti's USDC balance is 200. Again, Jyoti and USDC milke can determine how much data is in there, or how much tokens do they have. So similarly in the Solana world, this is how it would look like. Okay, this is the token program, this is the USDC mint, and this is Jyoti's address. Given कि यार ये token program जो है उसका USDT mint जो है उस पे ज्योति का address जो है, this is the public key where we are storing this data. We are deterministically, you can deterministically reach this address. Just how in this SQL table you would run a command that says select token amount from user balances where token mint is USDT and address is Jyoti's address. This would lead to a single row over here. Similarly in the Solana world, given the token program that you are dealing with, plus the fact that USDT is what you want to arrive at, or USDC is what you want the balance for, plus it is Jyoti whose USDC balance you want. Given these three things, you can always reach this address, जहाँ पे you will find कि अच्छा Jyoti has 200 rupees. So in the Web2 world, this is how you can reach Jyoti's balance. You can run an SQL query. In the Web3 world, specifically for the token program, this is how you can deterministically reach कि Jyoti के पास कितने वो होंगे. This is what wallets do. If you ever open a wallet, there is no easy way for the wallet to know how much USDT you have. It is very easy for it to know how much Sol balance you have, but all the other tokens that you have, it has to sort of climb through these public keys and reach your associated token address. Once it reaches your associated token address, it would know you have 200, whatever Jyoti tokens, or sorry, USDC tokens in there. So this process, or more specifically this address or this account, is what is called a program derived address. Why? Because you don't randomly generate iska public and private key. You don't call keypair.generate. You don't create a fresh account for storing Jyoti's 200 and put some data there. No, you derive this address. This address doesn't even have a private key. You somehow derive this address, and once this address has been derived, you put some data in there. So this is what a program derived address is. Similarly, for the bonk token on Poonam, given the token program and the fact that bonk is what you want the balance for, and the fact that you want Poonam's bank address or bonk balance, you can deterministically arrive at this PDA, and that is what a PDA is. That is why I said in your Uber program also, whenever in the future you create your own Uber program, see if I have a slide for it. In the future, when you create your Uber program, everything that you're generating from there will also be PDAs. We'll discuss that a little bit, eventually. But hopefully this is clear why this is a PDA. If this was not a program derived address, how would you know Poonam ka balance kahan pada hai? You would have to store that somewhere separately. Token program ka address is publicly available. Bonk ka mint address is publicly available. I can Google कि यार bonk का वो क्या है, bonk mint address. When I search for this, it leads me to this public key. तो ये तो मेरे को बहुत easily मिल जाएगा Google पे. This I can find on Google. What is the token program address? Token program address Solana. If I Google, it will very easily lead me to the token program. If I keep going through here, or it is a variable also in a few places, you can easily find the token program. If you remember, here also it printed creating token this on program, token program. So these two you can find easily. But I cannot Google, okay, given the token program this and the token, let's say, whatever, bonk token, this and the public key, let's say my public key, this, give me the ATA. Google will not return me this data. Google is not indexing this data. Google will index कि ठीक है भाई, token program is a big thing. I will store it somewhere in Google or wherever it is publicly advertised. Similarly, USDC, जब भी वो USDC token mint बनाते हैं, they publicly advertise कि this is where we have created it. Your public key, your friend's public key you can get from them. But you can't take these 3 seeds and Google. You can't Google कि यार ये और ये को मिला के जो ATA बनता है ना, प्लीज मुझे लौटा दो. Google doesn't know that. Google is not calculating that. If this was random, it would have been, everyone would have had to tell कि यार ये रहा मेरा ATA, ये रहा मेरा ATA. But since it is derivable, since it can be derived given this, this and this, you can automatically reach the user's address. So that is what a program derived address is. It requires 3 things from you. It requires कि कौन सा program है जिसके लिए आपको ATA चाहिए. This is actually incorrect. This should be associated token program. I'll come to what that means. This should be associated token program. So throughout the slides, this specific thing would be wrong. What I was saying was कि to derive this address, अभी मैंने code भी दिखाया था a while back. I showed you the code, right? I showed you this code. कि given 2 seeds, I was able to derive the final associated token address. In actuality, you need the seeds कि हाँ भाई पूनम के bonk token का balance क्या है. What were the seeds over here? My public key and my token. And similarly, what are the seeds over here? Poonam's public key, let's say, and the fact that the bonk mint address. These are the 2 seeds. You need this. Along with this, you need a parent program. When you say program derived address, it means कि ये जो address है ना किसी program के through derive हुआ है. It is a program derived address. This address is associated with a given program. Basically, कल को ऐसा ना हो ना कि let's say I create my Uber program. So, this is my Uber program, let's say. And this is your Ola program. We both created ride hailing competitors. So I say कि मेरी ride की information ना for Harkirat will be stored over here. Given the seed Harkirat, given Harkirat का public key is the seed. Given this seed, you can derive के where Harkirat's public information is stored. Harkirat का whatever address, name, they are both stored in this address. You can derive this from Harkirat's public key. This is the only seed. If this was the only seed, तो Ola वाला भी कह देगा यार. The Ola person will also be like कि यार we are also using the same seeds unfortunately. कि Harkirat's public address you can find over here. So to avoid this conflict, to avoid 2 different programs leading to the same account, whenever you derive a PDA, I repeat, whenever you derive a PDA, along with the seeds, you need the program ID. It is not कि हरकीरत से आप यहाँ पहुँचे. It is Uber plus हरकीरत से आप यहाँ पहुँचे. It is not that you reached this account from just the Harkirat seed. No, you reached here from Ola plus Harkirat's seed. So in case of a PDA, in case of any program that you create in the future, whenever you want to derive an account on that program, you will have to give the seeds. You will also have to give a program ID कि कौन से program से ये derive हो रहा है. This plus this is what leads to this. So the inputs, you might feel, this is a smaller example over here कि हाँ, given a token program plus Poonam plus bonk should be able to derive this ATA. This is a simpler example. This is not what exactly happens. Something else happens in actuality. But just for simplicity, can we say कि given this token program and given this seed and given this seed, we can reach the associated token address for Poonam? Sounds right. You can deterministically reach the associated token address for Poonam. So what are the three inputs if you want to derive an address? It is a program, which let's say in this case is this. As I said, in actuality it is something else. But let's say for now, for simplicity, let's say there is a single token program that exists. Us single token program address is our initial input to the derive wala function. The function that is deriving, first input is this. Second input is the seeds. Third input is, or the output is this case is the PDA. This plus this is what arrives over here. This plus this is what leads to, 400 or this specific account. This specific account is derived from number one, a program, iska address. Number two, a bunch of seeds, let's say Bonk and Poonam. And this is what leads to the third address over here. Seeds are actually more complicated. For example, a lot of times seeds are token program and seeds hongi, plain text strings. For example, this is one example. This is a good example of how it would be for, let's say, the token program. This is how you can derive the third account given account one and account, given these seeds and given the token program. In case of our Uber program, what would it look like? In case of our Uber program, it looks something like this. This will be the Uber program. Let me mark this in red. This is our Uber program. Anytime a user signs up on our website, we will create a new PDA. We will derive a new PDA for them. Let's say green accounts are PDAs. And we will say the seed for this is, let's say, user one's public key. So, yahan pe what would the corresponding thing be? Kya my program address is the Uber program. My seeds are just, let's say, Harkirat's public key. And this leads to this specific account over here. So this almost looks right. The only problem here is what if Harkirat ka address is stored somewhere else? What if Harkirat's first name and last name is stored over here, but Harkirat's address is stored over here? So in actuality, seeds look something like this. The seeds would be name, comma, Harkirat's public key. Harkirat's name is stored over here. And then another set of seeds would be address, comma, Harkirat. Harkirat's address is stored over here. For a single user, you might have multiple accounts. Harkirat ki pehli ride might be stored over here. Harkirat's ride number 1 or Harkirat's coupon code is stored over here. So for a single user, you might have multiple accounts. So the seeds will have public keys from time to time. Ki Harkirat ka name kya hai? It will also have some random, plain text English words. Ki iski seed hai name and Harkirat. Uber program plus the plain text English string name plus Harkirat leads you over here. Uber program plus address as a plain text string plus Harkirat ki public key leads you to this account. So for a single user, you might have multiple accounts. For the token program, you don't need to. But for a different program like Uber, you might need 3 addresses for the same user. So to derive, all 3 of these need to be deterministic. All 3 of these cannot be deterministic if, all of them have this same seed over here. Then all of them will lead to the same account. Hence, the seeds are, usually created like this. Kalko, if you make a full stack application, you will see seeds like this. Okay, name iska yahan stored hai, address iska yahan stored hai, and whatever coupon code for this user is stored over here. Do we understand this little bit? More than a little bit? Do we understand the inputs that lead to an associated token account? Uh, 80%. That's fine. Let me complete the whole thing, then I'll take doubts. But hopefully this is clear. Okay, PDAs are addresses derived deterministically using a combination of user-defined seeds, ignore what the bump seed is for now, and a program ID. ये सब मिला के एक public key बनती है. If you add the user-defined seeds, something else called the bump seed, we will come to what this is, and the program's ID is how you arrive at the public key. Cool. See if slides have something extra. Yeah, this is just the Uber example. Why is it going back? Oh, that's pretty much it in the slides. I think we can get to the code next. Yeah. Let's go into the slides from last week where we had written about PDAs. Let's read through this again and then let's try to code it. This pretty much covers the same thing. It says, the token program is a program. You create a token mint account from it, which is not a PDA, but you derive users associated tokens accounts given this token program and this token mint account and their public key. This is a better definition of it. But okay, let's not go there. I think I'm confusing you a little bit more. Let's discuss a small side experiment. A very small side experiment. What do we need to understand next? We need to look at the code. We need to understand what is happening in here. But if you look at it, it'll overwhelm you a little bit. But chalo, let me overwhelm you a little bit. This is the code that we had written. Let me open the corresponding diagram for it so it's easy to, look at. This is the corresponding address or diagram for it. This is the code for it on the left. Let's try to look at this code and try to see how does Poonam's associated token account get derived from everywhere. We saw this code a while back. It was working as expected. Let's try to go through the code from top to bottom. Let's try to inspect what is happening over here. What is this public key.find program address sync function doing? What is it taking as inputs? Seems like it is taking an array of elements as input and a program ID as input. But notice the program ID is not the token program ID, it is something else. So let's try to understand this code from top to bottom. Then we'll, then I'll take you to one more experiment/example. All right, bunch of imports at the top, ignore. One thing you need to know about this is कि एक तो token program address है on the Solana blockchain. There is something called the token program address. There is also something called the associated token program address. If I show you the code of Solana, if I look at Solana Labs / Solana program library. If you look at the Solana programming library, which is a bunch of, programs, smart contracts that Solana folks have written, you will find a token program, जो अलग से deployed है. You will find an associated token account program. There are two separate programs that are used to create tokens. हमने अभी तक ये देखा नहीं है. We haven't looked at this program, but there are actually two programs that exist on the Solana blockchain that make tokens possible. So until now, the diagram that we've been looking at is a little incorrect. Okay, there is one program called token program. There is another program called associated token program. This is what actually happens on the Solana blockchain. कि एक तो token program है जहाँ पे the real code is written for balances, how balances go up and down. Then there is another program called associated token program. This is the one that has the logic to create this account, put some data on this account. This is the associated token account. This is the corresponding program for it. So in actuality, Solana blockchain looks like this, or the token programs on Solana look like this. There is an associated token program. There is an old token program. Aajkal there is a new token 2022 program, if you remember, where the token 2022 program is a new implementation. यहाँ में थोड़े extra features दे दिए उन्होंने. This is the old token program. This was introduced, as the name suggests, in 2022. So there can be multiple implementations of the token program. कल को token 2023 program आ जाएगा, या 2024 program आ जाएगा. They might keep making the token program better. So these three are just different. These three are just different programs that Solana creates every year. This might have something special कि इसमें तुम metadata automatically add कर सकते हो. You can automatically add metadata in here. This might have something even more special. This has zero knowledge, something complex. You can't see each other's balances. If you know Solana is doing something like this, if you're not, that's fine. But long story short, token program keeps on improving. ये अलग से चल रहे हैं. And USDC might be first created from this token program. In the future might get created from token 22. Then in the future might get created from token 2024. But along with these, there is an associated token program. And what was the definition of a PDA? Let me go back to that very nice slide. Let me copy this and bring this over here. The definition of the PDA was, PDAs are addresses derived deterministically using a combination of user-defined seeds, number 1, bump seed, number 2, and a program's ID. These are 3 things that you need. If you want to derive Poonam's associated token account, what do you think are the user-defined seeds? क्या क्या चीज़ें मिला के मैं यहाँ पहुँचूंगा? And the answer is this token program का ID. I repeat, this token program का ID plus bonk का ID, the token mint of bonk plus Poonam's address. This is my set of seeds that will lead me to this guy. What is the other thing I need to put? A bump seed, ignore what that is. What is the third thing I need to put? And a program's ID. Given these 3 seeds, plus this associated token address, इन दोनों को मिला के, when you add these two, is when Poonam's ATA gets printed out. I repeat, when you add इसका public key and इसका public key and इसका public key with the associated token program is when this comes out. What is a PDA? Let me make this full screen. PDAs are addresses derived deterministically using a combination of user-defined seeds. ये 3 चीजें. Token program कौन सा use कर रहे हो? Are you using token program oldest one? Are you using token program 2022? Are you using token program 2024? That is the first seed. Which token mint are you talking about? I repeat, which token mint are you talking about? That is the second seed. Which user's balance do you want? कौन से user का ATA चाहिए? That is the third seed over here. Given these 3 seeds and a program ID, and this program ID is not this, it is not this, it is not this. It is a separate program called the associated token program. The name itself is associated token program. जब भी आप associated token account बना रहे हो, whenever you are creating an associated token program, that will be owned by this program. Token program does separate set of things. Associated token program does things on these associated accounts. वो आप इसका भी associated token account अगर होगा, इसका भी associated token account होगा. If there is an associated token account for token 2022 program or 2024 program or the oldest one, they will all be owned by this guy. So when you add these two is when the Poonam's associated token account is spit out. So if now I open this diagram on the right and now we go through the code, what is happening in the get associated token address function? It is taking 2 inputs. Mint address क्या है? Bonk. Owner address क्या है? Poonam's address. These are the 2 inputs that this function takes. But notice the inputs that it gives to find program address sync. It says public key dot find program address sync. Owner address. What is the owner address? Poonam ka address. Token program ID. What is the token program ID? This guy right here. And then the mint address. What is the bonk ka mint address? When you take these 3 seeds on the associated token program ID, iski ID pe, when you take these 3 seeds and this specific account as the owning program, then this deterministically returns you कि Poonam का associated token account क्या है. So Poonam's associated token account is a combination of 3 seeds, owner address, Poonam का address, token program ID, ये use कर रहे हो या ये use कर रहे हो या ये use कर रहे हो, and mint address which is bonk का mint address. Given these 3 seeds, what are PDAs? Address derived deterministic using a combination of user defined seeds. These are our combination of user defined seeds. A bump seed, ignore what that is, and a प्रोग्राम आईडी. तो बम्प सीड बचा इसमें से. इन दिस स्टेटमेंट वी हैव नॉट येट लर्नड अबाउट द बम्प सीड, बट अदर टू थिंग्स डू वी अंडरस्टैंड. के टू गेट एन एसोसिएटेड टोकन अकाउंट फॉर अ यूजर, you need 1 2 3 things on the associated token program. You do not need 1 to 2 things on the token program. I repeat, you don't need 1 and 2 on the token program. You need 1 2 3 on the associated token program. Why this distinction, Harkirat? Because this is how it was created. कि यार associated token program doesn't need to change very often or at all. तो ये तो constant रहेगा. This will be constant. But token program implementation we will keep on changing. We will keep on bringing more token programs, which is why this never changes. But these keep on changing over the times. Now, if you want to derive an ATA for a token that was created using original token program, तो आप ये थे input दोगे. अगर यही बना होता from the token 2022 program, so the second seed would have been token 2022 program ID. If the same thing was, generated from here, from the token 2022 program, if bonk was created from the token 2022 program, then this is how you would have derived it. You would have changed the second input to be the token 2022 program. So it depends on how the token was created. The bonk token, was it created using the token program or was it created using the token 2022 program? If it was created using the token 2022 program, then the way you will derive the user's ATA would be this, using the token 2022 program ID. If it was created like this, then this is how you would derive it. Do we understand this? Do we understand the code that is written on the left a little bit? Harkirat, who decides the order? कि ये ऊपर होगा या ये नीचे होगा? The token creator, the program creator, whoever created ATA, this program, they said कि पहली सीड हमें ये चाहिए, दूसरी सीड हमें ये चाहिए, तीसरी सीड हमें ये चाहिए. In the future, when you create your Uber program, like I said, you will have your seeds like this. Care user, name is present over here, user address or whatever, owner address. Address is present over here, and coupon code is present over here. Ride number 1 of this user is present over here. Ride number 2 of this user is present over here. The rider of let's say this specific address ka information is present over here. So rather than creating tables like this, as I said, this table has primary keys, this data model has seeds. That is the only comparison between a SQL table and a Solana blockchain account model. But let's do a quick poll. Let's see how are we doing. I made this very complex, so I'm sure this become a little complicated, maybe not. Let me know. Oh boy. All right, no worries at all. We will go one more time and we will okay, if you understood, basically feel free to call it or class is done, because there's nothing extra I'm going to teach after this. I'm just going to from scratch teach the same thing again, and in a more simpler example being a Uber example. Uber or decentralized Uber example is what I'm going to take. We are going to start from scratch. Ekdam simple se understand. How will you store data on the Solana blockchain for a decentralized Uber account? Then we will, or maybe I should look at Q&A for 5 minutes. Let me look at Q&A for 5 minutes. I'm sure some of you have questions related to, the ATA or something, so I can share that. PDs are naturally very difficult to grasp. I remember when a senior Solana engineer told me that it almost took a month for him to practically understand what PDAs are at work. So I suggest you go through it, PDA concept multiple times. I suggest the same thing. So doing SPL token create account just calculates the PD address. What else does it do internally? It doesn't just calculate the address. That is one thing it does. But it also creates the address. It also, what happens? Great question. So someone said, when you call this, what happens, Harkirat, when you call this? Let's look at the signature, right? Let's look at the signature of this transaction. It derives that address. That is one thing it does. But it also creates that address on chain. If I go to explorer.solana.com and I paste this specific signature, what does it do? It interacts with the associated token program. It calls create on the associated token program. Great question. Someone asked, Harkirat, ठीक है, when you call create token, तब तो you interact with the token program. When I call create token, if you look at this signature over here, when I call create token, what do I interact with? Yeah. On chain, I interact with the token program. If you look at it, I called token program pe initialize mint function. So if you look at GitHub, I showed you GitHub pe there were two separate programs. One was the token program, one was the associated token account program. What do I interact with when I call SPL token create token? I interact with the token program. I'm initializing the mint. I don't care कौन से user का. I'm not creating any associated token account. But when I call SPL token create account, what do I interact with? I interact with the associated token program. What program do I interact with? I interact with this program right here. To create this, what did I say? This ATA is sort of, generated using this associated token program. Associated token account is generated using the associated token program. So if you look on chain, the associated token program create function is what gets called whenever you are generating these ATAs. That's a great sort of, call out. All right. Few more questions, then I'll try to explain it. ATA not getting. Create initialize mint 2 ATAs, 2 public keys. If I mint 100 to mint account 2 ATAs, each got 100. Create a mint account, 2 ATAs from 2 public keys. If I mint 100 to the mint account, then 2 ATAs get 100 each. No, only 1 ATA should get 100. If you do these 3 steps, and if you mint 100, you will only mint them to one of the accounts, not both the accounts. Is that what you mean? Let me put your question on the screen. So if there is something obvious I'm missing, tell me. This was your question. Why do we need to create ATA and PDA for creating a token? SPL don't create token. After that, why can't we do SPL token mint? Why do we need an associated token account is a great question, for which you should, I will answer this here as well, but we covered this well when we did this class right here on, you should go to this class as well, Solana jargon programming models and tokens. Over here, in this slide right here, I took you through this diagram. Okay. Someone said a great question. Someone said, yaar Harkirat mint bana diya. I have created the mint. Why can't I simply mint tokens here? Why do you make me create associated token accounts for the user 1, separate one for user 2, separate one for user 3, and store values in there? Which is a very common question that you would get if you're coming from the Ethereum world. Because in Ethereum, everything is stored in a single contract. In Ethereum, token mint bana diya, ERC20 you deployed, you keep storing more and more data in that ERC token contract. But on Solana, there is a limit to how much data you can store in a single account, only 10 megabytes. So if millions of users have your token, you will not be able to shove all of their information here. And also, it's more cost efficient कि आप हर यूजर का अलग ATA बना दो कि अच्छा user 1, do you want to hold some USDC? Give me some money to create your ATA. I will store your data over here. Whenever you go away, I will remove this data. I will return you back your Solana. So on Solana, whenever you are creating a user facing application, whenever you are creating an application where you need to create a bunch of user accounts, you create these small mini accounts for users. You create these PDAs for users. कि यार user 1 का data मैंने यहाँ रखा है, user 2's data over here, so that when the user signs up, you ask them, कि यार give me the money for this specific account. And whenever the user leaves your platform, you return them the money. So it's a good way to distribute data across accounts versus shoving all the data in a single account. If you shove all the data in a single account, what is the problem? There is a limit of 10 MB. You can't, store more than 10 MB of. You can start to store. User 1 has 10 tokens. User 2 has 100 tokens. But eventually you'll run out of limits. So that is why this account-like model is followed. And that is a good question that someone coming from Ethereum might ask. Okay, why can't I create a token and why can't I simply mint the token? ये बीच का step क्यों हो रहा है? Why are you creating an associated token account? And as I said, you do this because you distribute data across various accounts. And thanks to the concept of PDAs, you can always reach these accounts. यहाँ से यहाँ मैं पहुँच जाऊँगा, यहाँ से यहाँ मैं पहुँच जाऊँगा very easily. So when a user one wants to check their balance, you using the PDAs, they can hop to this associated token account, get back their balance. What is the fourth thing? Associated token account ID. Yes. Let's go back to the slides and the official definition of a PDA. What is the official definition of a program derived address? कहाँ गई अच्छी थी वाली? This one right here. I removed it from there and pasted it over here. The official definition of a PDA is that program derived addresses. PDAs are addresses derived deterministically using a combination of user defined seeds, a bump seed, we need to discuss this as well, and a program's ID. ये तीन चीजें चाहिए तुम्हें. You need three things to be able to generate the user's, a specific program derived address. The example that we took was, this slide, is sort of very important. The things that I've written over here, or, there's a corresponding slide here as well, which sort of covers the same thing, but let's focus on this slide. And a few people are asking a link to the slides. Anyone can access, copy link. I will paste it in chat. The way the token program was created from the beginning, I repeat. Oh wow, so many people. That's very distracting. The way the token program was created from the beginning was... Please tell me I can paste these here. I cannot. Alright. कहाँ गया? Whoa, you guys can edit it as well. That is not cool at all. Did I give everyone edit access? Oh no, can view. Who deleted this? Not cool. All right. Yeah, what I was saying was this is very distracting. So let's go here. This is how token programs were introduced on Solana. Pehle the first token program came, which was the simplest. कि अपना you create a mint. The token program's responsibility is to maintain balances and make sure only if you transfer money, your token from one to another, it gets debited from your account, gets credited to the other person's account. The token program was the OG token program on the Solana blockchain. Let's make the programs over here red in color. When this was created, Solana engineers were like, abhi ke liye to ye hai. We have this for now, but in the future we might have a token 2022 program which will have some extra features. So they said that along with this program, we are going to create a separate program called the Associated Token Account Program. Associated Token Account Program. दो program बना दिए उन्होंने. They said the second one's responsibility is, ये जो दूसरा account है, इसकी responsibility is कि whenever a new user wants to hold the token. So, यहाँ से eventually people will create token mints. People will create token mints, let's say USDC mint. And when a new user wants to hold an account or hold some USDC, they will have to create an associated token account that will be created by this guy. This associated token account is not created by the token program. It is created by this guy. The logic to derive, given the token program and the USDC mint and Harkirat's address, the logic to derive this ATA actually resides in this associated token program. It does not reside in the token program over here. If you look at the code of associated token program, let's see, associated token account program. If I open this program, you will see it has a create function call. And if you look at the processor of this create function call, if you process create associated token account, then notice the function that it calls at the top. What function does it call at the top? Get associated token address and bump seed internal function. What does it take as the input? The wallet of the user. What code did we write? Okay, whenever we want to derive the address, what were we taking as the input? The first key was the owner address, the wallet of the user. What is the second key? SPL token mint info dot key, the token mint address. No, this looks different. Let's look at this internal function call. I'm just trying to show you the derivation that you were doing over here, the way you were trying to derive. Let me show you the way you were trying to derive this address abhi using your JavaScript code is the same thing that the associated token program also does. Whenever you call, create account over here, we saw this. Whenever you called create account, what were you interacting with? You were interacting with this guy. This guy is what creates this associated token account. If I go to the Explorer, what created that associated token account? There was a function call to associated token program create. This specific function call was what created this specific address for any token program. Now in the future, if token program 2022 came out, for this guy also, when you create a mint, you interact with this token program 2022. When you are creating the mint, then you only interact with this guy. But when you are creating user ATAs, user 1 ka associated token account is this, user 2's associated token account is this, then you are not interacting with this guy, you are interacting with this guy. The associated token program is what creates this and this account. That is why the PDA that is being generated, the program derived address that is being generated, what program is deriving it? Is it this? Is it this? No, it is this. It is the associated token account program from which we derive this. What was the definition of a token program, or what was the definition of a PDA? It was this. The definition of a PDA was, PDAs are addresses derived deterministically using a combination of user defined seeds. क्या seeds हो सकती हैं in this case? To reach here, I need to know this is the first seed. Token program 2022 का token है. That is my first seed. What is my second seed? What token do I want the ATF for? USDC mint. What is my third seed? हरकीरत का चाहिए कि रमन का चाहिए? Whose ATA do I want? So these are my seeds. A bump seed is something else. We will come to what a bump seed is very soon. And a program ID. What is this program ID? Is it this? Is it this? No, it is this. The associated token program is the program from which this is derived. Program derived addresses. Are we deriving it from here? No. Are we deriving it from here? No. These are just part of the seeds. क्या token 2022 program है या token program है? These are just the seeds. What is the program that is deriving it? It is this associated token account program. One more thing we have to discuss. Let me quickly discuss it. Something called the bump seed. This thing right here. Basically, what happens is when you try to derive, given this and the program ID, which let's say, is token program right here, given these two, when you try to derive an account, the account that is created might lie on the curve. I repeat, the account that is created, the public key that is created, might have a corresponding private key. And what was a PDA ka definition? कि PDA cannot have a corresponding private key. A PDA should be off the curve. So, unfortunately, अगर तो आप deterministically कुछ बना रहे हो, if you are saying कि this plus this, when you run it through some algorithm, some deterministic keys get spit out. It might happen that this deterministic public key has a corresponding private key. It might happen that if this is the ED25519 curve, let's say, it might happen that the private key public key lies over here. If the public private key lies over here, that means इसकी एक private key भी है. There is a corresponding private key of this address, which is why you have to make sure it lies off the curve. You have to make sure कि whenever you are deriving a public key, जो public key आई है, that should not be on the curve, that should be off the curve. The way that happens in Solana or in this algorithm is कि they add a fourth seed over here. जो आपने दिया plus a bump seed. They add another thing over here. क्या ठीक है, 3 तो तुमने दी थी ना. I am going to add a fourth one. I am going to add a fourth seed over here called the bump seed. This bump seed will start from the number 255. मैं 255 डाल दूंगा randomly यहाँ पे. अगर ये सब मिला के if all of your keys plus 255 plus the token program leads to something on the curve, then I will decrease this to 254 and try again. Then I will see, does a combination of all of these lead to something on the curve? If it does, then I will decrease this to 253. Then I will see, does a combination of all of these again lead to something on the curve? Then I will decrease this to 252. I will keep going until I reach 1. From 255 to 1, at least one of them will lie off the curve. और जौन सी पहली मिलेगी, the first one that I can find that lies off the curve, I will add that as the bump seed. So even though you give it a bunch of seeds, in our case we gave it the token 2022 program plus the USDC mint plus the user's account, there is a fourth seed that gets added automatically, and this seed is decided by iterating from 255 down to 1 कि भाई मैं ये ऐड करता रहूँगा, whatever 255 that doesn't work, 254 that doesn't work, 253, I will keep trying this until I reach a number जिसके बाद जो public key आई है, the public key that is derived, that is off the curve, that doesn't have a corresponding private key. So if you look at the code that we had written, this code, or more specifically public key dot find program address sync, returns you two things. It returns you the associated token account address, one thing. It also returns you the bump. It returns you कि यार तुमने तो मुझे 3 दिए थे, मैंने एक चौथा ऐड कर दिया यहाँ पे bump, and it tells you what that bump is. So if I now, if you run this, you will see the thing that gets logged is associated token address is this, and the bump is 255. So for this public key and this public key, thankfully the first bump it tried worked, but this can be 254 as well, 253 as well, 252 as well, based on how many times it had to find it. If you go back to the slides, you will see I have two sets of code. One called create program address, or this should be find program address sync versus create program address versus find program address. The thing that we are using here is find program address. This will iterate through a bunch of bumps to find the right one. There is another function called create program address. ये वो नहीं करता. This does not iterate through a bunch of bumps. This simply says कि यार I am going to create the program address given these seeds. तो यहाँ पे you should pass the fourth seed as well. या तो आप खुद निकाल लो चौथी seed क्या है, या तो you figure out yourself what the fourth seed is by checking कि जो PDA बन रहा है उसकी private key है कि नहीं. तो you put this inside a for loop, or you can just call the find program address sync function, which will find it for you. If you look at its implementation, the find program address sync, what does it do? Finds a valid program address. Valid program address must fall off the ED25519 curve. This function iterates a nouns until it finds one, which when combined with the seeds results in a valid program address. ये जो function है, its final definition would look something like this. कि यार अच्छा ठीक है, you gave me these seeds and this program ID. The find program address sync will run a for loop for let I equal to I equal to 255, I is greater than equal to 1, I minus minus. If, or const public key equal to, then it will under the hood use this create program address. कि यार ये create program address है, and इसमें I will pass the user seeds, I will pass whatever the user gave me, plus I will add the bump over here. Okay, I will start from 255, and this will again be the program ID that the user sent to me, So this is how find program address sync works under the hood. Under the hood, it will start iterating from 255, go up to 1, use this function and then check क्या ये जो public key है, if public key let's say lies on curve, अगर ये public key ED2551 curve पे lie करती है, then it will keep on continuing. If it doesn't, then it will return the public key. Did you guys understand what I wrote over here? Do you guys understand the concept of a bump seed? कि यार हम तो यहाँ बहुत easy बन रहे थे. We kept our life very easy. We totally hid the complexity of a bump seed when I called find program address sync. But find program address sync under the hood has a very big for loop like this. Starts from 255, goes up to 1 and calls another function called create program address sync, which takes the original seeds plus the bump seed that you have added and tries to find a public key from 255 up to 1 जिसका कोई private key नहीं है. And when it finds one, that is the public key it returns. We can actually look at this on GitHub as well. Okay, what exactly is the real implementation of find program address sync? Or if I go over here in node modules, I can find it. Or somewhere in Solana/web3.js, if I search for find program address sync, I can't find it. But somewhere here in packages, addresses, source, address.ts, program derived address. Yeah, somewhere here you'll find it. If someone finds it, let me know. And if you look at the implementation, it'll look very similar to this. But let me take a pause here. I've now introduced the third concept of a bump seed. How many of you were able to understand it? User defined seeds, hopefully we understand. Program ID, hopefully we understand. Do we understand the bump seed as well? Let's do a quick poll. ये तो किसी को नहीं समझ आया. 72%, 71% understood it. Totally fine. We have another 30 minutes to go. So we will start from scratch and understand now everything from first principles again. Okay? The last 30 minutes, think of this like a new offline video where we are learning about PDAs from scratch. Next 30 minutes, let's try to first understand if you are creating a Uber-like application today. If you are creating an Uber-like application, what would its schema look like? What would you store in the database? And you will see, Kirat, it will have two tables. Table number 1 will store the user's information. Let's say, user ID, user name, and user's date of birth, and gender. These are the 4 things it will store. That is one table we will have. Kirat, I will call this the users table. And similarly, I will create another table called the addresses table, which will store, given a user ID, what is their street name, what is their building name, so on and so forth. What is the city, what is the country. This is how we will store data in the Web2 world in an Uber application. ID 1, name Raman, date of birth 01/01/1992, gender let's say male. And the user with ID 1, their address is, let's say street name, Delhi, building, let's say DLF, city, let's say Delhi. Something like this. This is how you will store the data for a user 1 in 2 separate tables. How would you do the same thing on the Solana blockchain? On the Solana blockchain, everything is an account. So let me put these two here on the left. This is how we do it in the Web2 world. How would we do it in the Web3 world? In the Web3 world, you will have सबसे पहले your Uber program. This is your Uber program. Given this Uber program, यहाँ से अगर आपको यूज़र 1 की इंफॉर्मेशन स्टोर करनी है, इफ़ यू वांट टू स्टोर द इंफॉर्मेशन ऑफ यूज़र 1, इफ़ यू वांट टू स्टोर this row right here, how will you store it? This row will be stored in an address which is derived from this program and has the seed users, 1. अगर आपने ये दो seeds ले ली, that leads to an address जहां पे this user's name is stored, date of birth is stored, whether there are a mail is stored. Just how in SQL you would run a query that looks like this: select star from users where ID equal to 1. यहाँ पे what all input did you give? Users was a 1 input, ID equal to 1 was another input. यहाँ पे what were the seeds that you chose? Users and 1. This is where you will be shoving all of this data. And similarly, where will you be shoving all the address of the user? You will be putting it somewhere here. Addresses, 1. Okay, given these two seeds, I am going to shove the user's data over here. Things like 1 Delhi, DLF Delhi. Do we understand this much? Okay, just like you would run SQL queries over here to find a user's details. Here you would run the function find program address sync. You would run this function right here, which will take what all as an input? It will take the first key would be a string, simply a string like, let's say, addresses. The second string would be कि किसका चाहिए भाई, user ID 1, let's say. These are the seeds, and what would the token, the account, the program ID be? It will be the Uber program ID. This function would return you a string or a public key that will lead you to this specific address. And similarly, if I replace the first seed over here with users, it will lead me over here. Do we understand this much? Can we do a quick poll? We understand this much. Sort of. 85% understand. It's like, okay, not bad. Given we understand this much, the next step is, okay, PDA has a very solid definition. PDA is clearly say that program derived addresses can not have a private key. A program derived address can only have a public key. There are multiple reasons for this. Okay, the PDA, if it doesn't have a private key, then no one can sign a transaction using it. That is a very big security thing. Okay, this specific PDA doesn't have a private key. If it is ever signed, it can never be signed. If it is ever signed, it is somehow signed by this program. We will get to that. But this can never, since it doesn't have a corresponding private key, no one can sign a transaction using it. PDAs cannot have a private key. The problem is, आप जो algorithm run कर रहे हो, find program address sync, whatever algorithm it runs, it might lead to a public key. It might lead to a public key जिसकी corresponding private key हो. Unfortunately, whatever algorithm you are running to take these seeds and convert it into a public key, that may have a corresponding private key. You don't know. The probability is very low. If this is the ED25519 curve, then most addresses lie off the curve. This is an address that lies over here. This is an address that lies over here. Most of them lie off the curve, but some of them will lie on the curve. This one is lying on the curve. What does lying on the curve mean? It means इसकी private key भी होगी. It will have a corresponding private key as well, which is why even though you give only two seeds, a third seed is appended over here. एक तीसरा seed यहाँ आ जाता है. The third seed is appended over here, and this seed starts from 255 and goes down to 1. कि यार Uber program users 1 plus this bump seed, if you add these three, does the public key lie over here or does this public key lie over here? If it lies on the curve, तो भाई run it again for 254. Now, does it lie off the curve or on the curve? Let's say it lies on the curve again. Then you run it for 253. You keep doing this until it lies off the curve. When it lies off the curve, then you stop. So this bump seed is something that you have to add. So that the public key that is generated is off the ED25519 curve. So what I was saying was कि यहाँ पे ना the find program address sync function hides a lot of complexity from us. We तो simply used the public key dot find program address sync. यहाँ पे in case of this Uber program, I would pass things like the owner's address, that is this public key, a string called, let's say, addresses, and then the owner's address. I would pass something like this, and I would say this is the Uber program ID, whatever that ID is. This is how I would find, this public key. But under the hood, you find a program address sync finds the bump for you as well. It starts from 255, 254, 253, finds the bump for you, and for that bump, it returns you the address as well as it returns you the bump. ये जो find program address sync function है, it is not simply deriving it. It is adding a seed to it, 255, 254, 253, 252, and finding the publicly, this address जहाँ पे private key नहीं है. And that is what it is returning to you. So the thing that it is returning has an associated token account address. It also has a bump. क्या 255 पे जाके finally I was able to find a public key that doesn't have a corresponding private key. Or 254 पे जाके I was able to find a public key that doesn't have a corresponding private key, so on and so forth. So this is how, this is what the bump seed means. If you look at the official definition again, PDAs are addresses derived deterministically using a combination of user-defined seeds, a bump seed, and a program ID. So now it depends कि bump seed, are you delegating the logic to find the bump seed to this function, or are you writing it yourself? You can also write it yourself if you want, or you can call this function. It will automatically iterate from 255, 254, 253, find the right one and return it to you. So you can either use the find program address sync function, or whatever this does under the hood, which it just iterates from 255 and goes down to 1 and starts to find a public key jiska there is no corresponding private key for it. You can write this logic yourself also. This uses the create program address sync function, and ये जो create program address sync function है, ये तुम्हें कोई भी public key लौटा देगा. It will return you a public key with or without a private key. It doesn't care. इसका the only goal for this is to calculate the derivable public key. If it has a private key, it doesn't care. But the find program address sync function, it does care. If you look at the official definition here, it says find a valid program address. This will give you an invalid program address also. This will give you a valid program address. Valid program addresses must fall off the ED25519 curve. This function iterates a nonce. What does a nonce mean? Iterates this number, starts from 251, goes down to 1, until it finds one that when combined with the seeds results in a valid program address. So until it finds ones which when combined with the seeds, ये थी user defined seeds, ये थी my bump that I added over here. I will keep iterating until I find a public key that doesn't lie off the curve, doesn't lie on the curve, and then return that. Do we now understand the bump seed a little bit with this example of Uber? And the answer could totally be no. Let me know. Okay, 88% is great. 89% is even beautiful. Cool. Was there something else? There's one more thing. One more experiment over here at the end, which is here we are using the find program address sync function. It returns you a bump, right? यहाँ पे, let me revert all of this. Not that it will matter. It returned you a bump over here. What if मैं नीचे ये code भी डाल दूँ? I am writing some code right below it. This is the ATA that I got, the associated token account that I got when I only gave the user seeds. I did not give a bump, and I called find program address sync. Here I am calling the other function, create program address sync, जहाँ पे I will have to give the original seeds as well ये दोनों तो आएंगी ही, प्लस आई विल हैव टू गिव जो बम्प यहां से आया था, वॉट एवर बम्प केम फ्रॉम हियर, I will have to give that bump as well. Then this and this will lead to the same public key. Let's try that out. Let me copy this again. And then let me copy this right below it. I don't think you need any of this. User address, token mint address, token program ID, bump. So I've written two things over here. This code above this guy and the code below. Code above we already saw. Okay, this is the user's address, this is the token mint address. We called public key dot find program address sync, that returned us the ATA, that returned us the bump. So this we already saw. Now what I'm doing below is I am calling public key dot create program address sync, not public key dot find program address. This will actually find a program address that doesn't have a private key. This will not worry about finding it. It'll just derive whatever comes out, and if it has a private key, it has a private key. But the inputs that I'm giving it are, जो inputs मैंने यहाँ दिए, the user defined seeds plus the bump that is returned from here. If I take this bump and shove it at the end, then this function will return the same account as this function, or this function returns. This one finds the PDA and appends it. Sorry, this one finds the bump and appends it. यहाँ पे I have manually appended the bump. So this and this gives you the same answer. The goal is to understand कि what is this doing under the hood. Under the hood, it is running this only, but it is running it from 255, 254, 253 like that, and finally arriving at a bump. Whatever bump it returns to you over here, give it over here. Now if I run it, you will see the public key that came here using find program address sync, and the public key that came over here using create program address sync. They arrive, they're the same, and the inputs are different. यहाँ पे inputs are user defined seeds and a bump. यहाँ पे inputs are just the user defined seeds. This guy appends the bump to it. Cool. All right. Time for Q&A. Tomorrow when you create your own contract, right, you will be creating a lot of these PDAs, which is why it's a very important concept to know. So, sir, while transferring tokens to others, does the ATA of mine call the system program, as you told that the ATA has no private key for signing the transaction? Yes. The ATA has no private key for signing the transaction. But what was the definition of a PDA? The definition of a program derived address was, if I show you the original definition, we skimmed over one detail on it. Where did it go? Let me show you the official docs. The definition of a PDA is, a PDA provides developers with two main use cases. Determinism, we discussed this. The second one we haven't discussed. Enable program signing. The Solana runtime enables programs to sign for the PDAs for which are derived from the program ID. अगर आपने associated token program ID use करी है to derive it, if you have used this program ID, this program can sign on behalf of this ATA. So whatever address is defined from a program, that program can sign for it. And this is why, even though there is no private key, still, you will find signatures on chain. The signatures, the Solana runtime is written in a way that whatever addresses are derived from a program, that program can sign on behalf of this address. So, if there is another, well, you have to understand CPIs for this, but if there's another program that expects कि यार तूने transaction sign की होनी चाहिए, you should have signed a transaction, versus this doesn't have a private key, so how will it sign a transaction? The answer is the associated token program ID can sign on behalf of this transaction. That is exactly what is written over here. The Solana runtime enables, the Solana runtime में ही ये logic है कि enables the program to sign for PDAs for the PDAs which are derived from its program ID. The PDA associated token address is derived from this program ID. So this program can actually sign on behalf of this PDA. token 2022 program on Solana is initiated on its Genesis block. No. Token 2020 program to came very late. Token 2022 program, as the name suggests, got introduced in 2022. Solana has been working from 2018. So no, it wasn't introduced in the Genesis block. It was not recently, but deployed much after the token program, which was deployed much after the token Genesis or the Solana Genesis. Could you explain the practical application of this? Where will we use it? When we create our own programs? Yes. You will use PDAs when you create your own programs, or until now, we have just been using, get associated token address functions like these. Until now, thankfully, we have only interacted with the SPL token program. And the SPL token program has a function called get associated token address. So we have just been calling this get associated token address function. The goal was to understand iske andar kya chal raha hai. What exactly happens inside the get associated token address function. And can you see this function gets an address by calling public key dot find program address, gives you the owner, program ID and mint. So jo logic मैं बाहर run कर रहा था, the logic that I was running over here is the same logic that runs inside this function get associated token address, which comes from @solana/spl token. So thankfully, all of this detail is hidden from us in this specific library. The @solana/spl token hides how can we arrive at an associated token account. But if you want to write it yourself, then this is the logic that we wrote ourselves today. In the future, when you create your own programs, so wahan pe you will have PDAs. You cannot store everything in a single account. If you create your own Uber, application, and if you want to see a real world, or not a real world example, like a bad example where we have built this is video that sort of covers the same thing. This video of mine, we write a contract as well as the front end for it. So when we are writing the contract, you will see, we are generating PDAs for this application. I think this is a simple e-commerce application, something like that. So that is where it will sort of be used. The ATA stores the user balance. That is correct. The user ka balance for a specific token is stored in the ATA. So this is what the diagram looks like. The balance of a user for a specific token is stored in their ATA. Any chance the associated address has a private key? It does not. There is no chance of the associated address having a private key, because when you call associated token address .create, वहाँ पे भी ये same for loop run होता है to check is there a private key, is there a private key, is there a private key, and it finds the bump, and the correct bump is where the this specific address is chosen and stored. So this address is chosen by the associated token address program by iterating from 255 back to 1 and finding the right bump जहाँ पे कोई private key नहीं है. ATA का owner who? ATA का owner is the token program. The token program, not the associated token program. ATA का owner is the token program. You said bump is also needed to generate PDA, but what is the bump? Yeah. So a bump is needed to store, and I don't know if this is an old question, 947, or it just came 3 minutes ago, so it's not an old question. The bump, as I said, is it is not necessary कि अगर आपने ये 3 seeds ली, if you take seed 1, seed 2 and seed 3, and if you pass it through this create program address sync function, this is the real function that takes seeds and program ID and returns you an address. Here, if you give it 3 random seeds, it might lead to a program. It might lead to a public key, जिसकी corresponding private key भी होगी. It might lead to a public key that has a corresponding private key. And hence, what you have to do really is take the user given seeds and add a 4th seed on top here. Start this seed from 255, 254, 253, keep going like that until you find a public key that does not have a corresponding private key. So let's look at the official docs. They write it in better English over here. PDAs. What is a PDA is fine. What is the seed? Or what is the bump is what we need to learn. How to derive a PDA? Let's start here. The derivation of a PDA requires 3 inputs. Optional seeds, predefined inputs like strings, numbers, or whatever, used to derive a PDA. These inputs are converted to bytes. That is exactly what we are doing over here. What are the inputs? These 3 converted over to bytes. User address, token program ID, mint address. Bump. an additional input with value between 255 and 0 that is used to guarantee that a valid PDA, what is a valid PDA? A PDA that is off the curve is generated. This bump seed starting with 255 is appended to the original optional seeds when generating a PDA to bump the point of the ED25519 curve. The bump seed is sometimes referred to as the nonce. So what is the bump seed? Or if you look at this, what is happening over here? Here you called find program address function. You called this function right here. What does this do under the hood? Here, given your seeds and your program ID, it will add a bump to it. It will be like, here I'm going to call create program address with the seeds that you gave and a bump which starts from 255 and the program ID that you gave. Is this a valid PDA? If not, I will decrease bump by 1. Example 254. I will try again. Doesn't happen. 253, 252, 251. I will keep decreasing this bump until I find a valid PDA. When I find a valid PDA, I can be like, okay, good to go. This is the PDA that I'm returning. If you understand PDAs well, most of your interviews will be fine. I'm saying well, people would ask you how not directly but indirectly what are PDAs. For example, one question that was asked to me in my third web interview was how are tokens stored and how is metadata stored. So back then Metaplex was used, or even today Metaplex is used to store data. So there is another similar PDA, which is the metadata PDA or the Metaplex PDA that I sort of explained in that interview. So very common thing you need to know of if you are eventually interviewing. This tells how much knowledge of Solana you have. Okay, what is the find program address function? How is it different from the create program address function? How does find program address use create program address under the hood? This does not guarantee that whatever it is returning will not have a private key. This does not guarantee that whatever it is returning would be a valid PDA. This does guarantee. If you called find program address, it guarantees कि मैं check करता रहूँगा जब तक I find a valid PDA. When I do, I will return that PDA and the corresponding bump. So create program address may return you a public key that has a private key. Find program address will return you a public key which has no corresponding private key. The examples will find program address, create program address. Canonical bump is another term to know. The canonical bump refers to the first bump seed starting from 255 that derives a valid PDA. For program security, it is recommended that you only use PDAs to derive from a canonical bump. Yeah. So basically, if you want, you can actually be like, I won't use the first bump. I will not use the first bump. I will use the second valid bump, or I will use the third valid bump. But the canonical bump is what you should use to derive, addresses. Hopefully that clears up what that is. Is this a PDA? It's very hard to look at an address and tell if it is a PDA. But the best thing you can do is go to SolScan and put the address, and thankfully these guys let you know if it is off the curve or on the curve. And if it is off the curve, then yes, it is a PDA, most probably. Let's look at this. If I open this, it tells me is on curve false. It is off the curve, which means this is a PDA. Now what are its, this is a token account. This is most probably an ATA, right? This is an associated token account for this Misha token. And what is SolScan telling you? This is not on the curve. It doesn't have a private key. An off curve address is an address which cannot have a corresponding private key. So this address doesn't have a corresponding private key. It is off the curve. And what is the sort of the specific address? It is a token address. You see an owner field over here. That is a public key. You see an owner field over here. That is a public key. Versus if I go to Postman and paste this specific public key over here and send, I see an owner field over here. That is the token program. Very important question I would ask in an interview. Okay, who is the owner of this specific address? And you will say, Kirat, the owner is this. The owner is not this. This is basically a token called Misha. This is the person who owns, let's say, whatever, 280,000 Misha token. This account ka owner is still the token program. What did we write over here? Initially, what did we learn? We learned this is what the token program looks like. Mint account is owned by the token program. Associated token programs accounts are also owned by the token program. Postman is clearly telling me that the owner is this. It is just that the sole explorer is telling me. The explorer is sort of, parsing the data inside. It is parsing this data and figuring out that iska owner, not this owner, not the owner that can change the data, but some owner field over here. Kiske token hai? Who is the owner of this associated token account? That is present over here. So yes, this Misha token or this specific address is a PDA. How do I know? Because if I go back to my original code and replace the user address with this woman's address, let's say I would assume this is the woman's, I don't know, this person's address, and token mint. What is the mint of this Misha token? This guy right here. So this token mint and this user address, when I run my code to derive the public key, you will see the address that it popped out was 2TNWB. And is that the address that you sent me? That is the exact address that you sent me as well. So is this a PDA? Now I have proven to you that it is a PDA, because when I call find program address sync on the Misha token mint and your friend's whatever public key, then it prints out this AT account, which is this. All right. I feel like Solana is somehow centralized because my owner of account SP is system program, and if they wanted, they could do anything to my account. Am I right or wrong? You are wrong. The ऐसे तो Ethereum could change its run. Okay, this is what happens, right? This is this bunch of miners. This is 100 miners that are currently securing the Solana blockchain. They have checked the Solana runtime, the code that they're running. Let's say they're running, some Rust code, some index.js, whatever. When they start the Solana runtime, they run something like this: /Solana-runtime. They have a certain version of the Solana runtime running. Let's say version 1.1. All of them are running this. इस version में तो सबने check किया है कि the system program isn't doing anything shady. The system program is part of the Solana runtime. Everyone is running this. Everyone has checked के system Solana runtime में जो system program है, it doesn't do anything shady. Now let's say the Solana people say कि we are releasing version 1.2, and in this version 1.2 they have changed the system program. They have done something shady here. So what would happen? All of these validators would check कि आपने कुछ shady किया है. If they have done something shady, they will not run version 1.2. They will keep running version 1.1. Same logic can be applied to Ethereum then, right? Since the system program is part of the runtime, if the runtime is ever changed, then of course, if the miners accept the new runtime, everything will fail. The miners need to make sure that wherever they are getting their Solana runtime from, that is a trusted source, that is an audited runtime version, and there's nothing shady in there. So it is not like Solana founders can come and quickly change the system program. No, the system program is part of the runtime. The runtime, whenever it changes, or whenever the Solana runtime version changes, wahan pe they can do shady things, but you can always check. And same thing can be done on Ethereum then. Why is there an owner concept of Solana? I don't see any EVM. What is the reasoning behind it? Yeah, it's just how data is stored, right? How would you figure out who can change data? If in the future, let's say you are creating a Uber application, the way you create it in Ethereum would be you have one very big contract. Wahan pe you have functions. And let's say somewhere inside these functions at the top you have an owner. Okay, this is going to be the owner of this specific address or contract. And whatever is the function, let's say, create ride. You can be like create ride function, you will have a check at the top. Okay, whoever is calling this create ride function is the same person as the owner. So yes, in Ethereum, this is how you do checks. Okay, who can change data of a contract? Who can update a contract? But in case of Solana, since there are so many accounts, I repeat, since there are so many accounts, you are storing all this data not in a hash map. You don't have a balances hash map like you would have in Solidity. You don't have the concept of a hash map in Solana. A single address is not storing an array of balances or a hash map of balances. It is all, or sorry, whatever it is called, mapping in Ethereum. Everything is stored in various accounts. So, if you create an Uber application in the future, then all of these accounts, who decides who can change the data? That's where the concept of ownership comes. Whoever owns this account, which let's say is this, Uber program, can change. The user wants to change their first name, they will interact through the Uber program, change it over here. User wants to create a ride, they will interact with the Uber program. That Uber program has access to change data in here. That is why all the associated token accounts that you saw are owned by the token program, because token program ka code hai, validated audited code hai. That is what is changing data in here. That is why the ownership concept comes, because data is fragmented in so many accounts. Regarding the upgrade authority, in EVM, upgradable smart contracts allow us to add new features, but we can't remove old code. Does the same apply to Solana? You can do whatever you want in Solana. You can literally change the complete contract. You might have a full-fledged contract. You might, convert it into an empty contract. So as long as the upgrade authority is set, in case of Solana, you can upgrade the contract to be anything. Some kick-ass Web3 project suggestions. I needed to get a job ASAP. Create some contracts, and if you are already good at either of these, and if $1,000 a month or to $15,000 a month sounds lucrative, get in touch to 100x devs on Twitter and let us know. Cool. A lot of people are asking project ideas. The one thing that fascinated me a lot, and you will have to spend some time figuring out how it happens, is price locks. Price locks are a feature in Tensor. They basically let you long and short NFTs. So you'll have to, there are a lot of things to figure out over here. Number one, you need liquidity. You need people who are, willing to put up their NFT for whatever, borrowing for some fees. So it's basically betting on the price of an NFT to go up or down. This is a great, super impressive contract if you can write. And there's another one that I thought of recently. Someone said, it's just a program to try out. You learn something from it, which is a game, like an on-chain game, where the first person comes and puts 0.1 Sol. So now this game has been initialized, and the winner of this game currently is, let's say, Harkirat put 0.1 Sol as the first player of this game. Now, in the next 24 hours, someone can come and put 0.2 Solana, and this amount will go down to 0.1 Solana in the next 24 hours. So I can come and immediately become the next winner of this. Let's say this is Raman. So Raman can immediately be like, Acha, Harkirat is the current winner. I want to be the current winner. I will put 0.2 Sol over here. So the balance becomes this much. But if no one comes for, let's say, almost 24 hours, then the amount of money you have to put goes down to 0.1 Sol again. So it could be anywhere between 0.1 plus 0.1 to 0.1 plus 0.2. And then people keep on doing this. The amount keeps on going up. And third person comes, I want to be the owner. Fourth person comes, I want to be the owner. So on and so forth. The pot becomes very big. And the rules of the game is that jo bhi last winner hoga, that person takes the pot. Whoever is the last person to place a bet over here. And it'll get very difficult to place bets, because this amount will become very big very quickly. This will become, it's going up by 2 almost exponentially every time. This becomes itna Sol. Not everyone has this much Sol. But the contract clearly says, ki yaar dal doge, so you will take the whole pot. So whoever is the last person who takes all the money. Building this is easy. And the harder bit is going to be where, PDAs will actually come into picture. Yeah, yahan pe there's no need for you to historically store who gave how much. So you don't need PDAs. You will have a single account, let's say, jahan pe you are putting the complete price pool. You will have a single field over here called the current winner that will keep on getting updated in this specific account. The current winner is this. This field keeps on changing. This becomes problematic or more complex, and you have to create PDAs. If you have to allow users to pull out money as the pot becomes bigger. Basically, the reason this becomes very lucrative is if I'm the first person to put in, right, iske baad jitne bhi aa rahe hain, all the ones that are coming afterwards, I will get back some royalty from it. So if I put in 0.1 and right after me 0.2 Sol came, some small amount of this comes back to me, 0.002 let's say. And then the next person put 0.004. So some small amount of royalty comes back to me to be the first person jisne dala tha. And similarly, since the second person put money over here, they also get back 0.004. So what this does is, if I put my money in and after me 5 more people put money in, my money will be made. मैं fees में ही अपना पैसा तो cover कर जाऊँगा. So as long as I'm early, I will be able to make money even if I'm not the last winner. तो यहाँ पे you will have to store कि how much has this person redeemed, how much is pending for this person to redeem. People will, मान लो there are 20 transactions that happened over here. Person one will come and redeem some Solana. So you have to store that this person has redeemed 0.2 Sol, and after 24 hours someone else put in more money, then they will redeem more, this goes up. So here you have to create a bunch of PDAs for every user who has put money over here in the past. Basically here, when you come and put money, you have to create an associated PDA where you are storing the amount that I put, let's say, was 0.1 Sol. The timestamp that I put it up was, let's say, this thing, and the number of transaction of mine is, let's say, 0.1. I have the third transaction. I am the third transaction in this pool, and the fourth field would be redeemed. How much of the money I have already redeemed? It will initially be 0. As more and more people put money, you can redeem, and this amount goes up. This redeemed field is needed so that whenever the user wants to withdraw, we check how much does he deserve to get. Let's say 2 Sol. How much has he already redeemed? The rest of them we return them to them, and we increase this value by that number. So this is where PDAs will come into the picture. Do you understand the game? It's apparently a popular game that was done on Ethereum. I couldn't find it. A friend told me about it. And it is a good game. Whoever is able to find publicity on it will make a lot of money. You can always be like, I am the owner, or I am the creator of this specific game. So on every transaction, 10% directly comes to me. So even if you're not the last winner, you will still keep making 10% of every transaction. Good game, right? I know. Pretty good game. Alrighty. That is one project idea. Someone asked, so this is not a PDA, then what is it then? Let's see. This looks like a signed program ID. This is an account which has some Solana but is owned by a different account, which is a program. It is not a PDA. It is like the Mint account. If you open a Mint account, let me open a Mint account. When I call create token, I create a Mint account. If you look at this Mint account and look at the one that you have, this Mint account is owned by this is owned by the token program. Yeah, exactly. This is owned by the token program. Iska owner token program. Iska owner kaun hai? Who is the owner of this guy? Let me see. On DevNet. Who is the owner of this public key? It is the token program. It doesn't, and this has some data and has some Solana. The one that you have has no data, has some Solana, and is also owned by a different program. So this is a program that owns this specific account. This may or may not be a PDA. Most probably this probably isn't a PDA. It could be a PDA as well. This account's owner is a different program. This account has some lampports. This account stores no data. So it is just another account which is currently storing no data and is owned by this specific. It is not owned by the system program. It is owned by a different program. This 8MV, whatever this program is. And if I look at this account, this account is a program on, sorry, mainnet पे भेजा था ना तुमने, कहाँ गया तुम्हारा? There you go. No. This is the one that you sent, which if I look at it on mainnet is owned by this guy, and if you look at this guy, this is a program on Solana. This is the data that is stored in that program. All right. So the paid super 30 will, so it will be like, you should come 5 days a week. You may or may not find me in the office. Most of the days you'll find me. So basically Monday to Friday. And it'll more be like, you have been given a project. You have to build that project. And if you have a doubts, there'll be a TA. If not a TA, then there'll be me. To quickly build out that. For example, this game is one thing I would love to build. And just throw out this specific token game that I just talked about. So you will be building projects like these. If you're stuck anywhere, you can, ask the person who's in the office, TA, whatever, And if he doesn't know the answer, then you can ask me. If I also don't know the answer, then we'll figure it out. But it's just building projects like these. It's probably 5 days. I mean, you can come and go whenever you want. You have the office, but there's no official. There are like 1 or 2 classes that will happen on things like these. For example, how do you create a program like this? Let's say, this is a good class to take. It's also content for me on YouTube. So there'll be classes like these. Rather than that, there's no official set of classes. It's just, you working a lot. So that's why there's like a bare minimum coding that how can I come up with the idea of an NFT marketplace? Why did you have to come up for an idea? The idea is already out there. You just have to build it. What steps are involved in creating a play to earn game? I don't know. I haven't built one, but if I had to guess, the biggest challenge here is how do you know if a person is actually playing? For example, this is not a play to earn example that I'm giving, but there is this app that someone created. The more that you walk, and the more tokens you will make. So people created bots that would just walk every day. Someone created a physical bot, the hand is moving, so it fakes that the person is moving. So play to earn games mein, I can think of a challenge. How do you know if the user is actually playing, or they have a bot that is playing the game on their behalf? But that's pretty much it. What does it do? Probably people play with each other, and the more that you play, the more tokens that you earn. It's a way to incentivize people to play more and more. And on the other side, people are speculating on the token for whatever reason, buying it. So the people who are playing get a token that they sell to richer people who believe in the idea or whatever. All right. So in previous class, you told that miners mint deck currency, but sir, in stake also we can earn ETH or SOL by doing gambling. So here also another way we are minting only. Acha. So if you go to a gambling website and you win money, does that mean the government is printing more money for you? No, right? Someone is losing, so you are winning money. So if you go to stake and win Solana, it's not like new Solana has been minted. You won it from someone who lost it. So yeah. Question and a pull request review. Boy, what is that question? It's a long one. Oh. While working on it, I found this problem under IFC1. Let's suppose 2 miners had solved the block at the same time. Now both the miners will add their public key as the Coinbase so that they can receive the award. Now how will the blockchain know whom to provide the award of solving first? This is the URL to my live blockchain. The green border means that the miner has solved it. The orange means that the block has been taken from another miner, but sometimes both the miners did at the same time. Now how to handle the situation? So that's what happens, right? That will be a fork. If 2 people solve it at the same time, then some of them will accept the first one, some of them will accept the second one, and eventually whoever solves the next block will broadcast to everyone, and whoever was that person, their fork will be chosen. So what will happen in your case is there will be 2 folks. Some 5 miners got the first one's broadcast first, other 5 got the second one's broadcast first. They started to solve for the next problem. Whoever solves for the next block will broadcast this new blockchain to everyone, this new block to everyone, and whoever had the other person's block will have to invalidate that one and choose the other one. So wow, this is very cool. Where is the code for this? Seems like you've built. There you go. I need to read through this. This is very cool. This is exactly sort of what was wanted. I totally forgot about this repository. And contest pages, create and manage contests, manage user profile pages, new design for problems page. All right. Some people from Super 30 are also working on this. So let's see if I can review it. Yeah, I'll probably be the one reviewing it. Yeah, I will. Let me just tag myself as reviewer. I will forget about this. All right, let me open chat for one last set of questions, then we'll call it. Please block me for any Super 30 earlier, free plus 1600 expensive for me now. Peers, but sorry, opening a few docs. Yeah, don't worry about Super 30. It's fine. You can always join the free one eventually if there's another one. So don't worry too much about it. It's very highly experimental also. So is PD as PD is also an account which stores data of minted coins. Do we need to pay rent for this account as it is storing data? Of course you do. Of course, if you're storing some data somewhere, you have to pay rent. So yes, whenever you send your friend USDC from Phantom, I repeat, let me just show you. Let's say I have USDC in one account. I have USDC over here, 13.9. Let me send this to another account of mine which doesn't have USDC. Let me send it to whatever, this account, 0.1 USDC. Now, even though I sent only 0.1 USDC, I also have to create that specific account did not have a associated token account for USDC. So this specific transaction that I just did, let me show you the transaction on Explorer. I only sent USDC to my friend. Ideally, it shouldn't have charged me so much, but it charged me a lot of money because it had to create an ATA for the user. As you can see, this transaction, I had a minus 0.002 Solana. That's a lot of Solana for such a small transaction. But most of this Solana went over here because I had to create an associated token account for them. So even though this transaction, it took away some USDC from me, it also took away a lot of Solana from me because I had to create an ATA for them. What happens if I send the same person money again? This time I don't have to give them the ATA. So this is why this time I don't have to, pay as much money. The first time you're sending someone USDC, if they don't have an ATA, you pay for their ATA because you're the one who's sending them money. If you're sending via Phantom and Backpack, so Phantom and Backpack have that logic. If you're sending someone USDC and they don't have an ATA, you are the one who has to pay for that ATA. That is exactly what happened here. And as you can see, the associated token program create function was also called. You were the one who paid for this specific account. Good question. I have job assignment in Angular. I don't know anything about it. Same, sir. If no one says to me some good, I have no idea about Angular. I'm the worst person to test on this. I would quickly look at a tutorial and do it. But unfortunately, I just cannot help you out here. I've only done it once back in, I don't remember anything at all to help you out here. I will just say all the best and, quickly in a day or two, I don't know, learn through it and chug along. Raj, have you joined Super 30? If yes, I will put a Slack link in the dashboard somewhere. You can join from there. I haven't added it yet. I probably should. All right, this is done. This is done. All right, let's look at a few Notion docs and we'll call it. This is the first project I've built in the name of Trezor X. It's a wallet web app like Phantom. Very cool. Start building 7 p.m. this evening, not complete yet. What have you built? Very cool. This is like a wallet app, looks a little clean. And this is create a new token, attach metadata to your token. Very cool. I like it. I'm assuming this isn't finished yet, but yeah, this is good. Mainly I meant for anonymizing, right? How can we legally track account if there is last sufficient amount of transactions, like the location of the holder, or does the blockchain by itself? You can't track their address or whatever unless they've done something dumb. Basically, in the end, most people have an account on an exchange where they've done KYC. So if you have an account on Binance where you haven't done KYC, and if you ever withdraw from that account, send to your personal account and do something shady from there, then it can always be tracked. This specific account was initially funded by Binance, so you can always send a notice to Binance. The notice will Binance will have to oblige and give you the KYC details of the user. That is how you reach a specific user's address. But most hackers don't use their own KYC. They use some, bot of KYC from China. So it's very hard for you to reach them. I'm currently in third year, fairly studying about placements. I really love exploring the ecosystem. But the placements are happening simultaneously. I'll be graduating 25. What do you think I should do to level placements completely on the Web3 ecosystem? Try to get a grant. If you can get a grant, the life is easier from them. A lot of people got it like $2,000, $3,000, $4,000. Then maybe it's a little bit easier. Otherwise, I wouldn't recommend immediately, diving into web. I mean, you can also do it. It's like really depends on the person. I just don't like suggesting someone to take such a, I wouldn't even call it unpredictable, but let's say unpredictable path rather than a predictable campus placement. It's not opening. So you will have to decide, unfortunately. Not opening, answered, answered. Oh, advanced way to understand PDAs. And Delta Prime DeFi Hackathon, $6,000 in projects. And why ETH is better. There are more full-time developers working in Ethereum ecosystem than every chain by top 30 already. A lot of data over here. There's twice as much, okay, cool. Yeah, I mean, Ethereum is also pretty good. And, it gives you a lot of access to a lot of other EVM chains. We will be learning ETH for the same reason. But yeah, you gave a lot of links, which seemed like a lot of ETH bull links, which makes sense. But yeah, cool. This is done. One more Notion doc. Okay, this is done. I guess that is it. Oh, there's another one. This is my okay answer. Done that one. Not opening. All right. I think we'll call it here, guys. Thank you for joining. And I will see some of you tomorrow in the web dev class. Some of you in Super 30 in Noida, and everyone else on YouTube. Have a good night, folks. Bye bye.